Okay, so we already have our error sum of squares. We can already solve for the estimator of variance. Estimator of variance again is SSE for the error sum of squares over n minus p. Again, our p is equal to k plus 1. Our k is the number of independent variables, so we have one independent variable, two independent variables. So there are two independent variables, and then plus 1, therefore our p is equal to 3. So let's plug in these values. So error sum of squares is 372.508 over our n is 5, our p is 3. Error sum of squares is therefore 372.508 over 2. So what is the value of our estimator variance?
$71.5016.
71? Sure ka, 71. Kaya 372 ba yan siya? Divide mo 2.
0.254.
Pila to?
186.
186.252?
25. 254.
254. So yun yung bantayan. Kita nawa ha. Pag ang imuha biyang value kay 372, i-divide ni mo 2. Layo ra kaayo siya sa 71. Nakatong first kay mention. So di na nakamuting ka na siya discrepancy nga ang pag-divide of 2 kay layo ra siya sa kuan. Ang expected na value dapat.
Yes, miss.
Okay? So, kana careful lang kay I know daghan kag isolve makalibog siya. Pero careful lang tag yun kay mawagtang ka sa isa magsunod na na siya. So, any questions? Wala ra? Okay, if you don't have any questions, let's proceed to the next part of the discussion. So the next part is, since katong last time, we were solving for the correlation coefficient, it was raised nga, what if values sa atong correlation coefficient falls in an ambiguous value, patong somewhere 0.5, since the range of our correlation coefficient falls between 0 and 1. So if 0.5, can we still assume that there is a significant, there is a relationship? So to identify if there is a significant relationship, adto na ta sa hypothesis testing. So what are the steps in hypothesis testing? So same when we have to siya sa simple linear regression nga testing. The only difference is, instead of using T values, we will be using F values. So let's start from step 1. So step 1 is stating the hypothesis. So ang hypothesis for multiple linear regression is ang iyahang null hypothesis indicates that your regression coefficients B1, B2, and until pila ka B or pila ka variables is equal to 0. Or if ato siyang i-translate to English, there is no significant relationship. Kay silang tanan equal to 0 man. So our alternative hypothesis is therefore that there is a significant relationship. Or there is at least one J, or at least one of these values and dili equal to 0. Or there is at least one independent variable that has a significant relationship to the dependent variable. So it may be this variable or this variable. Basta isa nila. So the next is finding the critical values. So in finding the critical values, for now we will use 0.05 confidence level, and then sa katong ato simple linear regression, we only have 1 degree of freedom. So for this time, we will have 2 degrees of freedom, which is DFN and DFT. What is DFN? DFN is the degree of freedom numerator, and then DFT is the degree of freedom for the denominator. So how do we solve for the degrees of freedom numerator? So kani siya kulang siya. So our DFN, or the degree of freedom for numerator, is the number of independent variables. I know. It's n minus k. So it's the number of data minus the number of independent variables. So for example, sa katong practice problem natin from previously, so our n is 5, our number of independent variables is 2. Therefore, our degree of freedom for the numerator is 3. So for the degree of freedom for the denominator, we will use this formula. It's n minus k minus 1. Or simply put, kung ano siya numerator, denominator sa atong estimator of variance, which is n minus p. Kaya if ang atong p, k plus 1, and then ato siyang i-substitute din so doing basic algebra, and ang negative nimo kay mo ma-distribute both values. So ang imong n, maminusan na siya og p, maminusan pa siya og 1. O nang mo na ang ato ang degree of freedom for the denominator. So lastly, instead of using the T table, we will be using F table. So F table looks like this. So this will be our F table. So in this side, you can see the degree of freedom, degrees of freedom for the numerator. In this side, you can see the degrees of freedom for the denominator. So katong previously nga atong is solved using the previous data of 5, our numerator is n minus k, no? So our n is 5, our k is 2, our numerator is, our degrees of freedom for the numerator is 3. So ani ka magtanaw. So for the denominator, it's n minus k minus 1. So ang kani siya, our n is 5, our k is 2 minus 1. So 5 minus 2, 3 minus 1 is 2. So ani na ka magtanaw. Wherever sila mag-abot, mo na imukuha ang critical value. So going back, so we already have our first and second steps. Let's then move to the next step. So in the next step, you will then solve for the test value. So sa ato ang simple linear regression, ang ato ang gigamit diri kay kato computing for the t using the correlation coefficient. So for this time, mag-use sad ta sa correlation coefficient. So our R is squared divided by k over 1 minus r squared over n minus k minus 1. The next step is making the decision. This is where you will decide whether to reject or accept the null hypothesis. So if your test value, if your test value is greater than your critical value, you will reject the hypothesis, the null hypothesis. Pero if mali siya, you will accept null hypothesis. And then lastly, you will summarize the result. You will then identify if there is a significant relationship or there is no significant relationship between the variables based on your decision here. Any questions? Wala. Okay. So, moving on, let's try practice solving. So, let's identify the degree of freedom for the numerator and the denominator. So, our degree of freedom numerator is 5 minus 2. So, our degree of freedom for the numerator is 3. Our degree of freedom for the denominator is n minus k minus 1 is 2. So, checking our F table, our degree of freedom for the numerator is 3. Our degree of freedom for the denominator is 2. Therefore, our critical value is 19.16. So, ito na siyang inutaan. Our critical value equals 19.16. So, step 1 is state the hypothesis. So, our null hypothesis is B1, B2 is equal to 0. or translating to English, there is no relationship. Our alternative hypothesis or there is at least one coefficient is not equal to 0, or there is at least one significant relationship between the dependent and the independent variable. Next is finding the critical value. So we still use the confidence level of 0.05. Our degree of freedom for the numerator was 3. Our degree of freedom for the denominator is 2. So therefore, our critical value was kani, 19.16. So next is solving for the test value. So to solve for the test value, f is equal to r squared over k over 1 minus r squared over n minus k minus 1. So sa to atong r for this sample problem? Anyone can recall?
Zero 0.9893, Miss.
0.9893. So 0.9893 squared over k. Our k is 2 over 1 minus 0.9893 squared over n minus k minus 1 is n minus k is 2. So what is our test value?
Zero point 9583, Miss. 9583.
Sure. I don't think so. Lagi 0.9583 siya.
11.4951 is
Pila to?
11.4951.
11.4951. 11.4951 sounds more kuan. More sakto kaysa sa 0.9583.
45.98 dahil miss eh.
Okay, so 45.98, no? Kaysa may nailay answer diha.
03.
45 point,
9803.
pila to?
9803.
9803. Para mo answer tanan? So I think this sounds about right. So we can now then make the decision. So in making the decision, so making the decision is again if our test value is greater than our critical value, we will reject the null hypothesis. So our test value is 45.9803, and then our critical value is 19.16. Is it greater than or less than our test value?
Greater than.
So greater than. So what are we gonna do with our null hypothesis? Are we going to reject or accept?
Reject.
So reject. So we will then summarize the results. So therefore, since we are rejecting our null hypothesis, we will accept our alternative hypothesis. Therefore, there is a significant relationship between variables. Or if ato siyang i-more personalized to our kani problem, the GPA and age of the student affects the state scoreboard. Okay, so any questions? Clarifications? Okay. So I think, wait lang na. Okay, so sorry. Let's practice solving using your seat work from last week. So, can we call the what do you call this? We can recall the R value for this problem. This is problem number 2.
Isa ra man guro imong example, miss, pag F2F.
So, dili example, seat work. Naghatag ko og seat work ninyo last time. Mao ni ang data sa inyo ang seat work. Seat work number 2, yeah. Item number 2 ni siya.
Yes,
Kisa may nakahipo sa ilahang answer sa ato. Soft copy naman akong ipangayo. So, who can recall the value for your correlation coefficient for this data?
Kuan, miss, 0.9924.
So, our R is 0.9924. Okay, so let's first solve for the degrees of freedom of the numerator and the degrees of freedom for the denominator. Okay, so our degrees of freedom for the numerator is n minus k. Our n is 1, 2, 3, 4, 5, 6. 6 minus 2. Okay, 2 ato ang independent variables ay sa iyo narali ay x1 and x2. So next is the degree of freedom for the denominators. It's n minus k minus 1. 6 minus 2 minus 1. So our degrees of freedom for the numerator is 4. Our degrees of freedom for the denominator is 3. So going back to our F table, so our degree of freedom for the numerator is 4. Our degree of freedom for the denominator is 3. Therefore, our critical value for this problem is 9.12. Going back, so again, our R is 0.9924. Our critical value is 9.12. So, doing hypothesis testing for this problem, we will start with step 1. Step 1 is stating the hypothesis. So, our hypothesis, our null hypothesis is that B1 is equal to B2 is equal to 0. There is no relationship. Our alternative hypothesis states that there is at least one variable that has a relationship with the dependent variable. The next step is finding the critical value at confidence level of 0.05. So we have already identified our critical value as 9.12. Next is solving the test value. So solving for the test value, r squared over k over 1 minus r squared over n minus k minus 1. So our r is 0.9924 squared over our k is 2 over 1 minus 0.9924 squared over n minus k minus 1. So what is our test value?
Ninety-seven point 5606, Miss.
97.5606.
Yes,
Same
Miss.
values with the others.
Miss.
Same, Remo?
Yes, miss.
Okay. So 97.5606. Our next step is making the decision. Our FO and our critical value. So for our critical test value 97.5606, and then our critical value is 9.12. Our test value is greater than our critical value. Therefore, what are we gonna do with the null hypothesis?
Reject, Miss.
We will reject the null hypothesis. Lastly, we will summarize the results. So we will be rejecting our null hypothesis. So Anita, there is a significant relationship between the independent and dependent variables. Kapalo na tanan? Any questions, clarifications, concerns? Wala ra question. So if wala, I will proceed. So kani akong gitudlo ninyo is solving for the coefficients and everything manually. So if when you are dealing with regression problems na more than 2 ang inyong independent variables, medyo lisod na lang siya. So, I will teach you kung saan siya na makasolve mo niya by Excel. Sa ato ang exam, I will still be requiring you to do it manually, but for now, I will teach you how to do it in Excel. But wait lang. So, let me show you some the Excel. So, let's start small lang sa. So, using our so using our data sa katong nag-una na to na example, we'll be using this one, katong 550, state board exam, GPA, and age. So, using our Excel, na ay program ang Excel na makasolve ka dayon sa regression. So, to do that, sa inyong Excel, adto mo sa data na tab, and then sa data analysis. Kani siya. So, sa data analysis, na magawas nga table. So, naadri ang inait nga analysis tools, no? So, ANOVA, correlation, covariance, kani for your analysis, histogram, and all the other tests and things. So, now, for today, we will use regression. Okay, nag-solve ng regression. So, input, the first thing you do is input Y range. Ang sa Y range, yan yung i-input ang Y values. So, in our data, the state board exam scores are our Y values. Next is you will input the X range. So, inig-input sa X range, tanang X inyong input. So, ang output range, the output options, kaya din ninyo ibutang. Para same kung ano siya, same page. Kaya if mag-yung worksheet mo, open na siya yung worksheet direct. So, once you click OK, mugawas siya na ang data diha. So, mauna ni siya. Sa kanina data, so i-zoom out ha para makitaan. So, for this data, nakita na nato ang multiple R. Ato ang isolve ang multiple R before, nakukuha ta 0.989. So, same ra siya sa diri. Ang R squared, ato siyang isolve manually, kuha na to 0.978 for this problem. You recall, our number of observations is 5. Mao ni ato ang N. So, naa po diri ang ato ang estimator of variance. So, sa kanisat nga table, makita sa nato ang atong regression coefficients. So, direct your attention here na adri ato ang coefficients. So, ato ang intercept, so din hita makakuha ang ato ang regression model is mahimo kang y hat is equal to kani negative 44.81 plus 87.64 x1 plus 14.53 x2. Then ato pong makita sa table nato ang f value for our f test. And then we will also have the upper limit and the lower limit of our coefficients, regression coefficient. So instead of using katong tag-as na mga formula to get the confidence interval for our coefficients, iyahan na pong gibutang diri. So ang standard nga ibutang is the 95% confidence level. So if pagkuan mo, if i-state ni nato same sa simple linear regression, excuse me. So our B0, which is our intercept, is less than equal to, greater than equal to. So our lower limit is 342.755 or then our upper limit is 253.13503 or 1350. So mo na siya itong confidence interval for the y-intercept. So sa ato ang regression statistics diri nga part, na siya gibutang the r squared and adjusted r squared. So what does the r squared and adjusted r squared mean? Adjusted r squared. So same with simple linear regression, r squared is still the coefficient of determination. So r squared equals coefficient of determination. So our coefficient of determination kay dinha gyapon nato ma-measure if accurate ba ang ato ang model or reliable indicator ba ang atong regression model. So our adjusted r squared, gano'n naman tayo adjusted r squared. So sa ato amang, if you look at our r's, ang ato ang correlation coefficient is 0.989. Our r squared is 0.978. Our adjusted r squared is 0.957. So what does the adjusted r squared mean? So adjusted r squared means nga there are chance nga ang imuhang coefficient, correlation coefficient and your r squared are not accurate. There are chances man good nga nag-take into consideration ka sa variables nga dili unta siya lapok. So, example na kay problem and then daghang variables i-state sa problem. And then ang tanan rang variables ipuhang. Not all variables are really necessary within the problem. So, kung mag-adjusted or squared ka, kay para yung ma-take into account ang error variation. So, majority sa mga statisticians, mas gamiton ang adjusted r square kay mas kuan man siya, mas accurate. So, how do we solve for the adjusted r square manually? So, to solve for adjusted r square, so we will use 1 minus r squared and minus 1 over n minus k minus 1. So, i-solve nimo for But manually, it should be the same as this one. Na dinhi na to. Any questions? Question? Wala. Should we try another problem?
Yes, Miss.
Okay.
Yes,
So, so for example, kani, taas ni siya nga data. So, mo ni ito ang data for this one. Our y is full, our x1 is var length, and our x2 is die height. We have 25 observations. So again, data, data tab, data analysis, and then regression. So ang input niya automatic is ang values na ang data nga previous niya mo i-input. So ato i-delete and then choose na balik for this one. Same with this one. Then okay. So using this one, we can then conclude na ang ato ang model is 2.2638 plus 2.7443 x1 plus 0.013 x2 using these coefficients. Ano na ito regression model? Our confidence intervals for each coefficient kay mao pausa ni siya. Correlation coefficient kani r squared kani, and then our adjusted r squared is kani. Sakto, we have 25 observations. Our estimator of variance is 5.235. Our test value is 5.72. So, natin test value sa F. So, ato ang i-try upuha ang critical value. So, our critical value at 0.05, our DFN is N minus K, 25 minus 2. So, 23. Our denominator, N minus K minus 1. So, 25 minus 2 minus 1. 22. So, referring to our F table, So 23 and 22 ato ang kuan. So 23, wala man tayo 23 din 24 siya lahos. Let's use 24. And then our denominator is 22. So asa na siya pa dito? Diba? Wala. So 2.03. Our critical value is 2.03. I-compare na to sa atong F value, which is 572. So our F value is greater than our critical value. Therefore, there is a significant relationship. So any questions?
Excuse me, miss.
Yes.
Ang kaning R square, miss, ba kay squared ra ni sa katong correlation coefficients.
Yes.
Thank you, miss.
Sige, any other question? Sige, wala.
Miss, sa katong table, miss ba? Isa pa katay mong gibuhat, miss, nga 23 siya, then among 24. Always siya round up, miss.
Kung asa siya mas duol.
Okay, miss.
Okay, for example, atong value is 21. So, dili ka round up, mas duol mo siya sa 20 kaysa sa 24. So, whichever siya mas duol at ito ka.
If 22, miss, tunga man.
Mag-round up na ka.
Okay.
Sige, any other questions? Okay, so wala na. So if you don't have any other questions, I will be posting your assignment for this topic sa Canvas. And then, deadline will be on Saturday. End of day. Okay, para taas mong time. So, for next week, face-to-face mo, midterm exams. So, coverage for the midterm exam is whatever we discussed sa multiple regression.
Miss, saguhon niya pa ng formula, miss.
Gamay raman tag formula, masagura na ninyo eh. Gamay raman, wala may laing formula.
Multiple regression ra, miss.
Oh, multiple ra, dili na mag-include og lain.
Yes. I miss pwede maya sa recording ani, miss.
I'll see if madala na ko siya karon. Okay, I still have other things to do pa man. If ma-delicate ako siya upload. Sige, any other questions? Concerns? Clarifications? Wala? Okay. So, daghang late. Attendance na balik. Turn on your cameras.